In this lecture, I will share some important points about electric potential gradient. First of all, what is the definition of potential gradient and what is the expression for calculating potential gradient? We know potential due to a source charge is given as 1 upon 4 pi epsilon naught Q upon R, where Q is magnitude of source charge and R is the distance of point of observation from the source. It is very much clear, as R changes, potential will change. So what is potential gradient? It is the rate of change of potential with respect to R. So I can write definition of potential gradient. Potential gradient can be written equal to dV over dr. That is derivative of potential with respect to R. R means distance of point of observation from the source charge. So this rate of change of electric potential with respect to distance from the source charge is called potential gradient. Now we have to derive a relation for potential gradient. For that purpose, let me consider a source charge of magnitude plus q sign positive, and let me take a point within its electric field where a test charge of magnitude q naught and sign positive is placed. If I try to move this test charge toward the source charge through very small distance, let us suppose it is dr vector, then some work will have to be done because this test charge will experience a force of repulsion according to Coulomb law in this direction. So let me calculate small amount of work done. Small amount of work done during small displacement dr vector. Let me denote this small work as dw. By definition of work, I can write it is equal to F vector dot dr vector. So this is the definition of work, dw equal to F vector dot dr vector. It can be simplified to write dw equal to F dr cos of the angle between F vector and dr. It is clear from this figure, angle between these two is 180 degree. Cos 180 degree is minus 1, so I can write minus F dr as the answer for small amount of work done. Now by definition of electric field, we know electric field is defined as force per unit test charge. So I can write F is equal to Q naught E. By putting this value of force in the expression for small amount of work done, we can find potential gradient. So previous equation for work can be written as dw equal to minus q naught E into dr. If I take q naught to left hand side, I get dw upon q naught is equal to minus E into dr. By definition of potential difference, we know potential difference between points A and B is defined as work done in moving a test charge from A to B divided by the test charge. Using this idea, I can write potential difference dV equal to minus E into dr. This will give us dV over dr equal to minus E. hence the required expression for potential gradient. So we can say potential gradient due to a source charge is equal to electric field due to source charge at the point of observation. Here negative sign indicates that as R increases, potential will decrease because dV can be written as V2 minus V1 and dr can be written as R2 minus R1. Means if R increases, then potential will decrease. This is the significance of this negative sign on right hand side. That's all.